good morning, good afternoon, according to your time zone. So I hope my voice is audible to you, right? If you are able to hear me, please say yes in the chat box. So we are aware that you are able to hear us. Please say yes in the chat box. What about others? Okay, great, great. So welcome everyone. Right. So this session is going to be about the 5G overview. We have around 63 participants already. We had around 300 registration, and we are expecting a house full here. About this session, in this particular session, what we are going to talk about is we are going to talk about 5G overview, right? So when we say 5G overview, what are the things we are going to discuss, right? So Abhishek says has audio started. I hope everyone is able to hear me. If you're not able to hear me, please check your audio settings because many people have said that they are able to hear me properly. So you need to check your audio settings if you're not able to hear, right? So let's get started then. Yep. So about this session, we are going to have a 5G overview session here, right? So in 5G, what are the different terminologies? What are the different so what are the different terminologies what we have, and what are the different stakeholder, different business verticals, service verticals? Everything is we are something what we are going to discuss in this session. So the agenda of this session, before we get started, we'll just quickly go through the agenda of this session. Right. So in this
Sorry to interrupt. Is there any recording for this?
Yeah, we are recording this session and we will be uploading this on a YouTube channel, and we will be sharing our YouTube channel link in the text box so you can subscribe to that, and
Okay,
you can
okay,
see the video there. Right? No,
okay. Thanks,
yeah,
thanks.
thanks. Right. So now in this particular session, what we are going to discuss is we are going to talk about the evolution of 5G. As we know, the 5G started with the 2G started with the first cellular technique. Right before that, we had 1G and all, but hardly any of us have seen that. So 2G, then we migrated to 3G, and then we had 4G, which we are currently using. And now, finally, what we are going to do is we are moving towards 5G, right? So in 5G, what are the different things coming up? What are the different changes compared to 2G, 3G, or 4G? That is something what we are going to discuss. The use case is something which drives the 5G, right? So 5G use cases are very important aspects of 5G, and we are going to talk about the 5G use cases and scenarios, right? We are also going to talk about the 5G end-to-end architecture and how it is different how it is different compared to the previous generations, right? Deployment option is something we always look forward for interaction with the previous generations, and how do we really integrate it? There is a typical question which comes in our mind saying that, okay, what is the typical interaction what we have with the 5G or 5G with 4G, 2G, or 3G, right? In that scenario, what you need to do is in that scenario, what you do need to do is you need to talk about different deployment option and how it interacts with 4G or 2G or 3G for that matter, right? 5G core network overview architecture. So core network is going to play a major role and going to see a paradigm shift in the core network of 5G, and how it is going to be different than 4G. And we will talk about something which is very critical to 5G, which is called as SB. SB stands for service based architecture. What is going to be the service based architecture? How it is going to impact our networks? We are going to talk about those things in detail. At the end, what we are going to talk about is some enablers of 5G core network or the new features. I'll say we are going to talk about something called as slicing. We are going to talk about something called as MEC, which is multi-access edge cloud, right? Multi-access edge cloud, and then we are going to talk about orchestration. However, we have limited time of around 1 hour 30 minutes. We will see. We will try to cover all these things at a very basic level. If you have any more questions, we will be coming up with follow-up sessions very soon on each and every topic in detail. So we are going to topics one by one in detail in the follow-up sessions, right? But if you have any questions, please feel free to write us on email. So that will be I will be sharing all those details on the email as well. Right. There are few people who are writing in the chat box that they are not able to hear me. But if the majority of people are able to hear me, that then there is something wrong with their audio settings, right? So please check your audio settings. We will be uploading this video on the YouTube channel, so you will be able to see this video on our YouTube channel as well. The link of the YouTube channel is already shared in the chat box. Moving on, just few points to note, right? So this is an open session and we have a quite a mixed audience here, right? So what we are going to have is we will try to keep it at very, very basic level, and we will have some detailed session at a later stage. Request everyone to keep their mic muted. Whenever we will open for a question and answer, you can unmute your mic, but we will try to mute our mics as long as possible. Right. During our session, we will be keep taking questions in between. But if you have any questions for any particular slides, please try to answer, write your questions on the chat box. Right. So as long as you have any questions related to any slides, please write in the chat box instead of unmuting yourself and then taking up the question. We will have a 20 minutes question and answer sessions at the end of the session, but we will be taking these questions at the later stage also on our YouTube channel. So any questions you have, you can write it on our YouTube channel as well. Just to answer this, we will be uploading this on our YouTube and we will be sharing the link with all participants. So we will be sharing the link with all the participants. If you have any questions, feel free to write us on our email address, which is info@nanocellnetworks.com, or visit our website, which is nanocellnetworks.com. Just give me a second. There are people who are disturbing. Mm-mm-mm. 1 second. Uh, Kuldeep, I'm transferring the host control to you. So whenever somebody is unmuting their mic, please mute their mics. Right. So moving on, what are the things we are going to discuss here is like a little bit about me. I'm Sanjay Kumar. Right. So I'm Sanjay Kumar. 1 second. Sorry. So my name is Sanjay Kumar, and I have around 18 years of work experience and 12 years of training experience. The organizations currently I'm working with Nanocell Networks. Right. Before that, I have worked with HFCL, Reliance, Hutchison SR, Ericsson, Nokia, working with a company in Finland called as Refcon Training Services. These are some of the organizations I have worked with. Technology started my career with 2G, and even before that, with some indigenous technologies. Worked with 3G as well as 4G and 5G as well. Currently working, building my capabilities on 5G. Right. Now, coming to I have some experience with microwave as well as the optical fiber, worked in IP technologies, packet core of 4G and 3G as well as 5G packet core I'm working with, and some experience with VAS technologies as well. Typical products, telecom products, what I have worked with is Samsung, Nokia, Ericsson, ZTE, and Cisco kind of products I have worked with. Right. Now, coming back to the NanoCell Networks, the company I work with. So typically, we are into learning services. So most of the services are catered towards the learning part of it. So we are associated with a company which is managing the 5G test bed, and we are doing. So the company is called a CVIT, which is the Indian government-funded organization where we are managing all the 5G test bed and working with them. We are delivering trainings on telecom technologies, starting with 2G and going up to 5G and beyond. Training on data science and cloud, and talking about network and cyber security, and also some trainings related to soft skills as well. So these are our typical our five learning services that we have. The typical customers what we have is like these are some of our major customer, right? So where we have Cisco, Amdocs, Ericsson, Nokia, Kodiak, Orange, Siemens, ZTE, Vodafone, ZDSU, all these are our customers, right? So moving on, let's get started with our agenda, which is going to be 5G overview, right? So in this, what we are going to discuss is we are just starting with the 5G overview, and then we'll move forward with the further points. Now, cellular system, this particular slides talk about the evolution of 3G, third generation partnership project. We are not really going to spend our time here from 1G to 4G because it is assumed that you already have good idea about all these technologies. What is of our interest only 4G and its evolution. And typically, what we are expecting here is 2010. Typically, we say 2010, where we are expecting 20 Gbps in downlink and some 10 Gbps in uplink. So this is the typical, because if we talk about various generation in the past, our focus has been always onto the higher data rates, right? So whatever generations we had, we always talked about higher data rates. So in terms of higher data rates, what we are expecting in 5G is 20 Gbps in downlink and 10 Gbps in uplink. That is something what we are expecting in our 5G technologies. How we are going to achieve this, we are going to discuss all these things further. Right. So quick comparison, because many of us are already working on 4G, so wanted to have a quick comparison of 4G and 5G. What is the difference? What is the typical difference? So typically when I talk about latencies, the delays in 4G, the delays were like 10 to 100 milliseconds. And in 5G, we are expecting, like less than 1 millisecond kind of delays. Download speeds where 4G was promising up to 1 Gbps, 5G is coming up with 20 Gbps and more. So 20 Gbps is something what we are expecting. Frequency channels, when I say channels here, I'm talking about the frequency channel, not the bands. So typically people get confused whenever we say 800 megahertz, people start getting confused with the bands. So we are not talking with the bands here. We are talking with the channel bandwidths, which was typically 20 megahertz in LTE and 100 megahertz in LTE advanced. We had some 60-40 megahertz kind of LT advanced pro kind of releases, which we are not getting into the details as of now. We are expecting up to 800 megahertz kind of bandwidths. Core network, we will discuss this further in detail. In 2G, 3G, 4G, most of our core was hardware dependent. All these things were implemented with some piece of hardware. But in 5G, the core network is completely cloudified. So we will say completely cloudified network, where all the things will be based on the cloud. And we are going to use extensively two things. One is SDN, another one is NFV, software defined networking and network function virtualization. These are the things what we are going to discuss. Right. Now, subscriber density, we'll talk about this further as well. In 4G, our subscriber density was like 10 raised to the power 5. Well, that is 100,000 subscriber, 100,000 subscriber per square kilometer. But in 5G, what we are expecting is 1 million subscriber, 10 times of that in one particular square kilometer. Typically, till 4G, all our previous generations were typically designed for mobile broadband services. We tried to do something related to NB-IoT in 4G as well, but that was some kind of add-on features on 4G. But in case of 5G, we are typically talking about three service verticals, which is called as EMBB, Enhanced Mobile Broadband, URLC, LLC, ultra reliable low latency communication, and MMTC, massive machine type communication. We are going to talk about all these three things in detail. In case of 4G, typically network was designed for the base station. We try to achieve something with the home e-node, Bs, picocell, microcells. But in 5G, we will talk about something where we have to heavily depend on heterogeneous networks, right? In that case, we are going to have mixed kind of network. We will have from microcell to macrocell to the hotspot kind of technology. And how we are really going to achieve this, we will talk about all these things in detail, right? Now, a quick comparison, just following up with the previous slide. So IMT and advanced, which is typically considered as 4G LT advanced or 4G kind of function, and comparison with 5G, which is typically IMT 2020. Right. So when we look at a quick comparison of both, so typically in 4G, we were expecting data rates of 1 Gbps. This is called spiderweb diagram, which is a comparison between 4G, which is IMT advanced, and 5G IMT 2020. Why IMT 2020? We are going to discuss about that as well. So in case of 4G, we were expecting 1 Gbps kind of data rate. In 5G, we are expecting 20 Gbps. Now, one important aspect what we have achieved here is the user experience data rate. So in LTE, our user experience data rate was typically 10 Mbps. Now we are expecting every users to get almost 100 Mbps. The 3x spectral efficiency, how we are going to achieve, we will talk about it. The mobility to support up to 500 kilometer per hour. Latencies, we are going to talk about down from 10 milliseconds, we are moving towards 1 millisecond kind of latencies, which is going to be a very, very big enabler for a new service category, which is called as URLLC, ultra reliable low latency communication. We are going to talk about this in detail. Connection density, we are expecting around 1 million kind of devices in per square kilometer. And these are the two other areas which are not very important, but yes, they are actually related to network energy efficiency and some area traffic capacity. So these are the quick comparison between 4G and 5G. Moving on, 1G and 2G were typically designed for basic voice and SMS that we all know. Time on this. 3G and 4G were designed for video call, webs, and applications. The kind of growth what we have seen in last decade, it is very big growth what we have seen. That is because of 4G what we had. Now, what we are trying to achieve in 5G is, in 5G we are going to talk about wireless, everywhere, everything. So it's not only the users, the human beings which we are targeting. Our targets are much bigger in 5G. In 5G, multimedia services is only one part of the story. What we are expecting is to connect everything and with everywhere and everything. So what we are trying to do is we are trying to do M2M, which is typically machine to machine communication and connecting everybody and everything. We'll understand what do we mean by connecting everybody and everything. We'll talk about it. So 5G is not only about higher data rate. 5G is not only about broadband services. What else we are going to target in 5G? We are going to talk about in the next following slides. But yes, 5G is not only for the broadband kind of services. Moving on, so this is a very important picture, and what you see in every 5G documents and every 5G literature. So this particular picture talks about something called as service verticals. As I mentioned in the previous slide, 5G is not only about broadband, but it is, yes, one of the most important vertical of 5G, right? So that is called as EMBB. EMBB stands for Enhanced Mobile Broadband. Of course, broadband is going to play a major role and going to be the first milestone in case of 5G. However, 5G is not only about that. 5G talks about so many other verticals like URLLC. URLLC is called as ultra reliable and low latency communication, right? Ultra reliable and low latency communication. And the third major important vertical is MMTC, massive machine type communication. As I mentioned earlier, we try to achieve some of these things in LTE as well with the introduction of NB-IoT. There was some limitation with NB-IoT. It was mostly add-on feature on LTE, but in case of 5G, we are going to include this in the initial releases as well. Now, what are the typical characteristics of these three different service verticals? So in case of enhanced mobile broadband, we are expecting high rates. Of course, high rates we are expecting are 2010, 20 Gbps in downlink and 10 Gbps in uplink, which is going to be almost 20 times of 4G. 20 times of 4G, which is giving around 1 Gbps. So this is some breakthrough what we have here in the EMBB. What we are expecting other thing is enhanced broadband with many more features, tactile web, HD video calls and other things are not very new to the cellular networks, but yes, we are going to enhance this. And finally, what we are looking at is something called as FWA. FWA is called as fixed wireless access, where they also call it as wireless fiber. So providing fiber kind of data rate, providing fiber kind of data rates in the wireless networks, that is something what we are looking at, FTTX alternative. This is going to play a major role. This is going to play a major role in 5G. At the same time, we are also looking of different use cases where we can reach to the rural areas where the connectivity is an issue. And recently there were some articles they were mentioning that, right, 5G can be a big hit in the rural area where the last mile connectivity is a challenge and no other cellular technology was able to reach there, right? In MMTC, what we are going to talk about is larger number of devices, deep penetration, and power efficient. So larger number of devices, we are looking at 10 raised to the power 6 kind of devices, which are typically 1 million devices per square kilometer. We are also expecting deep penetration. We'll see how to achieve this, and power efficient. So we are expecting these devices to be very, very power efficient. How do we really achieve this? We will touch upon those points as well. URLCC. So going back, EMBB was the bread and butter for all the previous generation. sorry, MMTC was also tried in the form of NB-IoT and some other mechanism. However, URLLC is something which is very new to 5G. URLLC talks about ultra reliable, where our networks are ultra reliable and low latency communication, where we are talking about latencies of 1 millisecond and less. Typically 1 millisecond kind of latencies. And what this is going to do is this is going to bring low latency, high reliability, and going to talk about V2X kind of services, vehicle to vehicle and vehicle to X kind of services, where we can talk about autonomous cars, industrial automation. And one very important aspect to ultra reliable ultra reliable and low latency communication is the public safety apps. Public safety apps, we had some versions of GSM-R, and we had something called as LTR. LTR and GSM are typically categorized under MC services, where MC stands for mission critical. Typically, we had to create some new functionality in the LT and GSM network for mission critical kind of services, because they were completely not designed for mission critical kind of services. So we need to have Tetra and P.25 kind of techniques for mission critical services. Now, 5G brings one aspect is URLLCC, which is going to play a major role in public safety apps. Public safety apps, LTR and GSM are typically stands for GSM for railways and LT for railways, right? In public safety app, it can be fire, it can be metro station, it can be train station, it can be ports, airports. So we can have one aspect is URLLC, and another important aspect which we are going to discuss further is called as slicing. Slicing is also going to play a major role in case of public safety apps, right? So what is slicing, how it is going to move forward, we are going to talk about all these things, right? Now, moving on, so if you have any questions, please feel free to write in the chat box if you want to know something about these things. I will try to take up a couple of questions and then we'll move forward. Any questions as of now?
Hello, yes, I have a one question, Raghavendra this side.
Yeah, Raghav, please ask. Yeah.
For URLCC, you said means 1 millisecond.
Yes, that's correct.
Is 1 millisecond is for 0.5 for communicating that port and for 0.5 for returning on.
Well, not really, Raghavendra. So for that, we have to get into so many details of OFDM symbols and stuff like that. So for
Okay.
example, earlier what we had is we used to have one time slot, which is typically, one subframe, which is typically 1 millisecond, right? Now what we are going to do is we can transmit at a one OFDM symbol level. So our transmission time can be lowered much lesser than 1 millisecond. So, but we cannot really get into those details here. We have to understand OFDM and everything to understand that, how we're going to achieve this. So it's not only time slot level. Now you can transmit at a OFDM symbol level.
Okay.
Yep. Okay. Thanks a lot. So there is another question from Mr. Amit. How exactly we will achieve high bandwidth and low latency is related? So Amit, not really. So they are not pretty much related. So latency comes with the transmission time. So we have something called as OFDM transmissions. So we will be transmitting at the OFDM symbol level. So we need to understand that. And high bandwidth basically gives us the higher data rates. So they can have some relations in some manner, but they are not directly related, at least in the sense where we are talking about. Right. So I think OFDM is already covered in DWDM. So OFDM is not related to DWDM, right? So it is something different than DWDM. So we will talk about it at a later stage, right? So there is a question related to slicing. So we'll talk about it when we reach to that level. Now, some important thing here is about the 5G releases.
Just one question from Steve here. Just one from previous slide. So how much latency we are targeting for user plane and how much we are targeting for control plane in new radio?
So typically, if you see for user plane, we are expecting around 1 millisecond or less, and for control plane, typically 10 milliseconds. That is the typical time we're looking at here. Okay. Now, I'll take more questions at a later stage. So typically what we have is something called as 3GPP releases. So 5G is again released by 3GPP. A little contradiction here, but again, all the 4G and 5G releases are typically released by 3GPP, which is third generation partnership project. It was called as IMT 2020. IMT 2020 means it was supposed to get launched in year 2020. So that was the plan. However, because there was a push from the industry, there was push from the vendors and the operators, and many operators have started with their own standards, right? So 3GPP was pushed to release it early, so they started working it on 2017 and released it in multiple drops. Because typically drops are some kind of releases, different releases within the same release. So the release for 5G what we have is called as R15, release 15, release 15, and in release 15 we had multiple drops. One is called as early drop, one is called as main drop, and the third one is called as late drop, right? So these are the typical timelines. So when the early drop came somewhere between the end of 2017 and the initial for the first quarter of 2018, main drop came somewhere around Q3 and Q4, and 2019 second quarter we got the late drop. So 5G did not come in one particular release. So it came with multiple releases, which is called as early drop, main drop, and late drop. We had some features early drop. So in early drop, typically we talked about NSA kind of deployments. What is NSA? Known standalone deployments. What is known standalone deployment? We are going to discuss in detail. Just allow me a minute. In main drop, in early drop, typically it was NSA with EPC kind of deployments. So it was known standalone deployment with evolved packet core, which is 4G packet core. In main drop, it came up with its own core network. So 5G core network was planned in main drop. And in case of late drop, we have talked about a lot of interworking with 5G and 4G, and a lot of other interworking options were also given. We are not going to talk about the details of all these drops, but these are the typical releases. The next phase of 5G is coming with release 16. Release 16 is expected somewhere now, right? So release 16 ESN1 is expected sometime now, right? So we are going to have a lot of features in release 16 as well, right? Moving on, SA and NSA. So if you look at it, we had multiple deployment option. Out of that, we had 6 major deployment option for both SA and NSA. So if you see this, the first line talks about standalone deployment and the second line talks about NSA, known standalone deployments. If you look at option 1 and option 2, they are nothing but standalone 4G network and standalone 5G network. So standalone 4G and 5G network. So we are not going to talk much about it. In case of 4G, we typically call it as E node B. Here, typically we call this device as G node B, and we call this radio network as NR. NR is called as new radio, right? So there is nothing much to discuss in like option 1 and option 2. They are nothing but the standalone networks of 4G as well as 5G. What is more important here is option 5, option 3, option 4, and option 7. Please note these are not the only options, and they also have further details. So we are not getting into those details as of now. It is just at the overview level. So, but every option is further divided into multiple options. So we have master cell group, secondary cell group, and stuff like that. So we will not get into those details. So in case of option 5, in option 5, we had LTE node B. We had LTE node B, which has to be upgraded to support 5G, and that is called as NG node B, next generation E node B. Next generation E node B is nothing but the upgraded LTE node B, which is connected with 5G core. So we have LTE node B, upgraded one, and connected with the 5G core network. So this is the option what we have as option 5. So in this case, all our existing node Bs, if they can be upgraded to NG E node B, which is next generation E node B, they can be directly connected to 5G core and can support some of the functionality of 5G networks. Option 3, which is also going to play a major role in the implementation in the initial deployments, where we have NSA, LTE, and NR. So in this case, we had EPC network here. The packet core network is our packet core which was used in 4G. It is supporting both 4G radio as well as 5G radio. However, there is a limitation here. So using EPC and both the E node Bs, LTE node Bs and NRG node Bs, where LTE node B is going to play as a master and NRG node B is going to be a secondary node B. So this particular LTE node B is going to be a master node and this is going to be a slave or secondary node. Option 4 is, so Sumit has raised his hand, so we'll just wait for a minute and then we'll take a couple of questions here. Right. So option 4 is almost the same, but here what we have is EPC is replaced by 5G core, and now G node B is acting as master. So our G node B is now acting as master, but our LTNG, next generation E node B, is acting as a secondary. So this is master, and this is going to be the secondary one. Option 7 is similar to a mix of option 3 and 4, where we have 5G core network supporting both LTNG E node B, next generation E node B, as well as G node B of 5G. In this case, what is going to be master is our LTE node B. So this is something what we have is option 7, right? Please note, this is not all the information what we have. It has got lot of other details, lot of other complications. Who is going to be the master? Who is going to be the secondary one? How we are going to split the traffic between them? So there is lot of details involved in each and every implementation, right? So Sumit has raised his hand. Sumit, can you please ask your question? Sumit?
Yeah, it's clear. It's clear now. Thank you.
Please.
Yeah, hello. Hello.
Yeah.
This is
Please.
Abhishek here.
Yeah.
Sir, I just wanted to understand what is the difference between your LTE node and the next generation node.
Okay, right. So if you see now, let me just talk about it. It's a good question. So you are talking about the E node B. So there are three terminology what we have used here. E node B. Okay, let me just make it little bite. So we have used three terminology. E node B, which is typically used in 4G. Another one is called as NG node B, which we are using in 5G. And we have talked about G node B, which is again going to use 5G, but typically a part of NR, new radio, right? NR is new radio. Now, E node B is a typical device which talks about protocols which are like S1C and S1U, right? S1C and S1U are the typical protocol which we use in LTE. If you're not aware about it, I'm not sure if I will be able to cover that here. But yes, if you have those doubts, we can talk about this later. Right, so LTE E node B supports S1C and S1U kind of protocols, but NG E node B, 5G core network doesn't understand these protocols. 5G core network doesn't understand these protocols. So we have to have a new protocol set implemented in the E node B, and that can happen only with a software upgrade in the easiest manner. So we need to have some protocols like N1, N2, and N3 protocol. So we need to support N1, N2, N3 kind of protocols with this E node B, and that can happen with the software upgrade. And with that software upgrade, this new E node B will be able to support N1, N2, N3 interface. If you're not aware about it, no problems. We are going to talk about it, right? So this NG E node B should be able to talk about these interfaces. We will have certain protocols here, which we'll discuss later. Right, so this is a typical upgrade of a traditional E node B, and we are calling it as NG E node B, which should be compatible with the 5G core network. So there are questions, some questions related to it. We'll take those questions a little bit later. Right. Okay.
Hello, sir.
Here? Yeah, please.
Sir, I have one question about N1, N2, N3. This is protocol or like?
Please wait. Please wait. We'll come to that level and then we'll talk about it.
Okay.
Hi, Rashi this side.
Rashi, please.
Yeah, sir, could you please elaborate a little bit about 5GC in comparison to EPC in a 5G network?
We are going to do that completely in detail. So you have to wait a little more about
Sure,
it.
sure.
So
Okay,
we are going to talk about completely in detail about that topic. Yeah.
sure.
Okay, Prashant this side.
Yeah,
Can you go
we'll
in
take up the
the?
question a little later, right? So
Okay.
we will have 20-minute question and answer round. So you can note down your questions and we can take up those questions at a later stage. We have limited time here, right? So frequency band is again, I'm talking the 5G radio. So when we look at 5G network, typically we have two components to it. NR, which is called as new radio, connected to 5GC, 5G core. If you look at NR, we have a lot of changes, but if I look at the major change, it is nothing but the channel bandwidth. In channel bandwidth, what we are going to talk about is where in LTE, our maximum bandwidth was 20 or 100 megahertz. 20 or 100 megahertz in LTE and LTE advanced. In case of 5G, what we are expecting is up to 800 megahertz kind of bandwidth. So megahertz, the bandwidth is going to play a major role in LT radio, right? So other than that, the network architecture wise, there is nothing much difference. The only difference is earlier we had E node B and now it is renamed as G node B. But one important thing to note here, getting 800 megahertz band in a 900 megahertz band, 800 megahertz bandwidth in a 900 megahertz band or a band similar to that is not going to be possible. So what they've done is they have defined two different frequency bands for 5G NR. Out of that, one is called as FR1, frequency range 1, and FR2, frequency range 2. Typically in frequency range 1, we are going to talk about low frequency range, which is typically sub 6 gigahertz. So the frequency ranges which are typically below 6 gigahertz frequencies, and we are going to use the most prominent one is 3.5 gigahertz, which is typically used over TDD. However, from country to country, from continent to continent, these things can vary. I'm talking about some older G bands you can also use some previous frequencies. So if you are scrapping your 2G or 3G network, those frequency bands can also be reutilized for your 5G as well. But typically these 6 gigahertz band are not going to give us 800 megahertz kind of bandwidth. So these bandwidths are going to be much lower, but they're going to give you a higher coverage. So FR1 is suitable when you're looking for higher coverage and less capacities. So typically for MMTC kind of scenarios, where we are talking about massive machine type communication, we have to rely on such bands, FR1 bands. However, when we're talking about EMBB kind of scenario, enhanced mobile broadband, where we are looking at 2010 kind of data rate, 20 Gbps for downlink and 10 Gbps for uplink, we have to rely on 24 to 54 gigahertz kind of bands. And in that, our bandwidths can start with 550 megahertz, can go up to 800 megahertz, right? And with these kind of bandwidths, we are able to achieve 20 and 10, 20 Gbps in downlink and 10 Gbps in uplink. However, this particular scenario is called as MM wave, millimeter wave, right? So in MM wave, we are talking about very short range. So mostly this can happen only in the hotspot kind of scenario. So you can't really cover a couple of kilometers from these frequency range. So it is going to be mostly a heterogeneous kind of network, and it will happen with the fixed and mobile access. So it can provide fixed services as well as mobile access services. So this is something which is very new to 5G, so which is not used in any previous generation. So FR2 is a very important going to play a very important role in the 5G rollouts, where it is mostly going to be small cells. So small cell, if we remember, we always use those cells as a add-on services in our existing cellular networks in 2G, 3G, 4G. However, in 5G, the small cells or MM wave is going to play a major role. If you really need to know more about the frequency and what are the frequency bands being used in different countries, feel free to visit this website, which is called as nivicfree.fr. So this talks about different frequency bands and how they are allocated globally for various kind of services. So you can get the details. So there was some question related to the 5G bands. So you can get all these information on this particular link. I have mentioned the link here. Right. So FR2 is going to play a major role in case of 5G deployments, and mostly it is going to be a very intensive network, very dense network, with lot of small cells, and only in those small cells you will be able to achieve much higher data rate. So FR2 will be used for URLCC. Depends on the implementation. Typically, if you are talking about V2X and V2 like V2V kind of communication, small cells will not going to help with that. So in that case, you need to go with FR1. So in FR1, my typical consideration is the coverage. So because if I'm talking about the vehicles which are connected to each other, I have to talk about the higher range. If I'm talking about MMTC, I have to talk about the higher range. The coverage should be higher. So for those scenario, FR1 will be suitable. But for high data rates, FR2 is going to play a major role. Right. So Umesh, please wait for a minute. We will take your question after a couple of slides. Right. So FR2 is going to play a major role in EMBB kind of scenario. However, these are not the only three scenarios. Please understand, EMBB, FR, URLCC, and MMTC are not the three different use cases. They are the different service verticals which are created. There can be n number of scenario which can be a mix of EMBB and URLCC and MMTC as well, right? So in those scenario, we have to design our network in a different manner. So we need to have that understanding. This is just a broad segregation of the services in 5G, but end of the day, our network configurations will depend on each and every different kind of scenario, each and every use case what we are supporting. And to support that, we have something new in 5G called as slicing. Slicing is going to play a major role. What is slicing? We are going to discuss that in detail. Moving on, so 5G enablers, there are a lot of 5G enablers what we have as end-to-end I'm talking about. Cloud native, core network is going to be completely cloudified. Radio, we have some options to have as cloud networks, but it again depends on the implementation, how we are going to do it. Ultra dense network, we are going to talk about lot of cells covering different areas, very, very dense network. Massive MIMO we have already used, right? So we are going to talk about massive MIMO, where it is going to be a lot of radios, a lot of different kind of antennas as such. mmWave, we have already talked about it. High frequencies in the range of 20 to 100 gigahertz. MEC, which is multi-access edge computing, bringing user plane closer to the end user to enhance quality of experience of the end user. What do we mean by that? We are going to discuss at the end, right? Device to device communication for public safety verticals, right? So how to support public safety with D2D kind of communication. We will not get into those details as of now. NFV, network function virtualization. We have to decouple our software from the hardware and virtualize our complete network function. This is something what we are going to achieve with network function virtualization. We are going to talk a little more about it in our 5G core network. SDN, software defined networking. We are talking about separation of control plane and user plane, right? Control plane and user plane for efficient management. Slicing, we are going to discuss this in detail in a later slide, where we are talking about utilization of single physical infrastructure to create multiple logical network. So the best way to differentiate our traffic until 4G compared to 2G, 3G, and 4G, the best possible way to differentiate our traffic was QoS. However, QoS is also going to play a major role in 5G, but we have gone beyond that. Right? And in that scenario, what we are going to talk about is something called a slicing. So please note, so people get confused and they say, okay, slicing is something which is going to replace QoS. That is not correct. Slicing is going to play a major role in the network segregation, in the virtual networks, creating multiple virtual logical networks. In those networks, again, we will have a prominent use of quality of service. And of course, we had some words like OSS, SON, self-organizing network, and that is taken to the whole new level by orchestration. And we are talking about end-to-end efficient management of the networks. We are going to talk about most of these things in detail in next few slides. Right. Now, before we move to the next topic, evolution to EPC to 5G core, Umesh, you had a question. Can you please ask your question? Umesh, you had a question here. Can you please ask your question? Okay, so there is another question from Tejas in detailed view on physical layer. So in this session, we are not going to talk about physical layer in detail, But yes, we will have follow-up sessions which will talk about all these physical layer and other protocol layers and other stuff. Right. So let's move on. There is a question from Manish. It says, one second. Why high band has low coverage? So for that, we have to go back to the basics. The higher frequency, lower range, lower frequency, high range. So we have to go to the basics of radio waves, and I think we will not be able to discuss those formulas here. It is something related to the free space path laws. So you have to get into those details, Manish, to understand that. Right.
So can I interrupt and just
Yeah,
ask a
please,
question?
please.
Yeah, sir. Just you
Who
spoke
is this?
about.
Please say your name and then ask your
Yeah,
question.
there's Abhishek here.
Yeah,
So just wanted to know this. You spoke about two bands, frequency bands, right?
yeah.
One is the 6 gigahertz band, and
Hmm.
another is the 24 gigahertz and above band, right?
Yeah,
So which
correct.
will be the deployment? On what platform will the deployment happen?
Okay, so Abhishek, very good question, but I'll tell you one thing here. So if you see 5G is going to be not going to be having a generic deployment scenario. So most of the 5G deployments are going to happen based on the use cases, right? So depending on what is the typical scenario you are going with, right? And according to that, you have to go for the deployment. If you are going to deploy for the EMBB kind of scenario, of course, the major deployments are going to happen around FR2. But if you talk about MMTC kind of scenario, you have to, or URLCC kind of scenario, in those scenarios, you have to go for FR1 kind of scenario. So it is going to be use case based scenario. And of course, we are going to have a mixed kind of deployments where we are having deployment on FR1 as well as FR2. And now separating all these things based on the slicing. So slicing is going to add another flavor to these use cases. Right. So there are some questions related to how many slices and stuff like that. We are going to talk about all these things a little later. Right. Abhishek, does that answer your question?
Yes, sir. Yes, sir.
So
Definitely.
5G is going to be a use case intensive network, right? So it is not going to be a generic network serving all the things. It's not going to be a plain vanilla kind of network. It's going to be a use case intensive network, and deployment will vary according to the requirement of use cases, right? So it has to be completely different from one use case to another one. Right. Okay. So moving on, this is the typical LTE-EPC network architecture we had. So we had E node B. So we had E node B, node B. We had MME, S gateway, NP gateway, HSS, which is called as home subscriber server, and MME is also connected to MME. And then we had PCRF, and all these things are finally getting connected to the PDN, packet data network. This is something what we had the EPC network architecture, right? It has come up with some problems. So what are those typical problems? We are just going to talk about some of the typical limitations with EPC. The very first limitation is too many protocols, right? So MME, just to take an example. So this is just an example. It's not the complete summary of all the protocols. MME used to diameter protocol towards HSS, S1AP protocol towards E node B, GTPC towards S gateway, and SGS AP towards MSCVLR. So it just had so many different protocols, and because of so many different protocols, it was not scalable. You can't really connect your EPC network to different networks, right? So it was having so many protocols, and it was really difficult to maintain those many protocols, standards around those protocols, right? So it was really difficult to have all these things. They were not manageable in that sense, right? The second limitation is closed network, right? Now when we use WhatsApp, when we use Facebook, when we use Google for that matter, all these companies are getting benefits of our data. However, operators were not able to do it. Operators were not able to do it. So what they did is they tried to implement something called as SCEF, which is called as System Capability Exposure Function in LTE. But the typical use cases for that was only IoT, Internet of Things, right? So typically our LTE network, EPC networks were not open networks. The third party services cannot get access to your EPC network. They cannot get benefits of EPC network. Now, how do we really manage it? We will see later. The gateway selection was not possible, so you cannot choose different S gateway. However, there was an option to use different P gateways, which are connected to one S gateway. and that was typically done based on some kind of thing, information called as APN, access point name, right? The fourth limitation was completely hardware-based architecture. However, it is not completely true anymore. Now we have something called as VEPC, virtual EPC. But if you look at initial deployments, all our initial deployments were typically based on some hardware. Either those hardwares were some ATCA-based hardware, ATCA-based hardware, or they were some hardware which were vendor proprietary hardware like XGW, extended gateway, stuff like that. But typically, all our initial deployments were completely based on the hardware. However, at a later stage, we try to achieve something called as VEPC, which is nothing but virtual EPC, which can be deployed even on the public cloud like AWS or Azure. Whether operators are going to do it, I'm not sure about it, but there are options to deploy your virtual EPC on AWS and Azure kind of networks as well. Even you can have your private cloud as well. So all the scenarios were possible, even VEPC, but it was not native cloud. It was created on a cloud at a later stage, but it was not a native cloud. So what we are going to do in 5G, hardware-based network elements in 2G, 3G, 4G, what we are going to do is the completely cloudification and softwarization. So this is typically related to these two things. We are going to migrate to completely virtualized network and sliced network, and we are going to talk about all the network functions. So there are no definition of hardware devices in 5G core. It is only going to be cloud-based kind of 5G core. Dedicated core network, right? So dedicated core network, now we don't have dedicated core network. We will have lot of flexibility with the core network. Functional entities, we will not have any entities anymore. We are going to talk about something called a service-based architecture, which is typically going to talk about API, application programming interfaces. We call it as RESTful APIs, and they are all going to use some HTTP2 kind of protocol. What do we mean by that? We are going to discuss in next few slides. Some proprietary protocols we had. Now all these proprietary protocols are moved to RESTful APIs, right? Not scalable because they are all hardware based. They were not scalable, right? Some new things here, exposure to third parties. So we have come up with a new device called a new function. I'll not say device, new function called as NEF, network exposure function, where your network and user capabilities can be exposed to the third parties, which can be used to bring in some new revenue streams for the operators. It also supports some backward compatibility as well as forward compatibility, right? So we are going to talk about all these things completely in detail, but these are some of the major changes compared to 2G, 3G, 4G core in the 5G core, right? So SDN NFV, there is a message from Amit. It says NFV widely used in 4G North America. So not only North America, Amit, it is also going to get used in most of the networks. So many of the operators worldwide has started implementing NFV and SDN even in 4G. So it's not completely new to 5G, but the difference is the idea is 5G is going to have native cloud kind of implementation. However, it was later adopted in 4G and previous generations. So I hope that makes sense, Amit. Right. So you are right. Nowadays, most of the implementation is happening on NFV and SDN kind of technologies. Right. So moving on, what we are going to do is, so we had a packet core in EPC where we had serving gateway, PDN gateway. This was our control plane, completely control plane. This was our mix of control plane and user plane. So S gateway and P gateway both were doing control. However, this was separated here. So here, this part was control plane and this part was user plane. But when I talk about, okay, so there is question some related to Kubernetes and all. So let me just come to that level and talk about it. So in case of S gateway and P gateway, we had something called as CP and UP combination. But what we are going to do in 5G is something called as CUPS. Please note, CUPS is not again new to 5G. It was already started implementing in 4G. But in 5G, the initial deployments are going to be completely CUPS-based architecture, which is nothing but control and user plane separation. So what we did here is, we have separated control plane and user plane, where the upper part is going to be pure control plane and the lower part is going to be the pure user plane. Now, what are the major changes here? So our MME is typically replaced by something called as AMF, what is access and mobility management mobility function. We will talk about it. This is similar. Please understand, Rajat, just wait for a minute. I'm not talking about these things in detail here, just to give you an idea. So AMF is something related to MME. AUSF and UDM is something related to HSS. PCF is nothing but similar to PCRF. SMF is a combination of MME, S gateway, and P gateway control plane. So anything related to MME, S gateway, P gateway, some of the functionality has brought into SMF, and UPF is nothing but S gateway and P gateway user plane. So these are the typical things what we did here. We have separated our control plane and user plane, where control plane part is taken care by AMF, SMF, and some more devices, but user plane is completely taken over by something called as UPF, user plane function, right? Now what we did here is, so this separation, what we see here is, this architecture is called as reference point architecture, reference point representation, where we are talking about AMF, which is typically similar to MME. SMF is a combination of MME and S gateway and P gateway, like a control plane. AF is nothing but application function. PCF is policy control function. UDR is uniform data repository. All these abbreviations are given in the next slide. UDM is Unified Data Management, AUSF authentication function, and NSSF. Please note all the functions are not included here, right? So there are some of the functions which are not completely included here. So we'll see some of those functions in the further slides. But some new function here, we are going to talk about it. So what we did here is, so this is the reference point architecture, but this is not how 5G is going to be. This is just for our understanding, and we have defined some N-based interfaces. Typically, they come up with some questions related to N, why they have used N. I have no idea. So in 4G, they were using S. Now they have started using N as the name of all these interfaces. And there was a question related to this. So we have N1, N2, N3, N4. These are all different interfaces, and there are some protocols running on these interfaces, right? So what are those protocols? We will not get into the details of those protocols in this session, but we will have some other sessions for that to talk about protocols in detail. But these are name of the interfaces, and all these interfaces are named with some N, right? However, this is not how I'm going to have my 5G core network. 5G core network is going to be slightly different, and how it is going to look like, we will see in the next couple of slides. So these are just the abbreviation of all the network function which we have talked about. Now, this is something which is going to be very important aspect of 5G, which is called as SBA, service-based architecture. Now we look at this. Here, no device is defined as a hardware device, but they are all defined as some kind of function, F. They all end with F. Most of those are ending with F. F is called as function. So they are all defined as a software applications, and they are all connected to each other via a service bus, and that is why we call it as a service-based architecture. They typically talk to each other with RESTful APIs. What is RESTful APIs? That we are going to discuss in the next couple of slides. So they talk to each other in RESTful APIs, right? And they are all communicating with each other. So typically they have a reference point, which is like this, and the name of the function. So they talk to each other by using RESTful APIs, and there are no point-to-point connection. And all these functionality, what you see here. So all these functionality, what you see on the top, this is all created as VMs. Please understand, this is something related to the cloud. So all these functions, what we see here, they are all created as virtual machines in a cloud infrastructure. So they are all created as a virtual machines in the cloud infrastructure, right? Now, when we talk about it, so all these functions are created in cloud infrastructure, and this is the control plane part. In the user plane part, we have just 5G RAN, radio access network, which is typically called as NR, new radio, and UPF, user plane function, and connecting to DN, data network. DN is nothing which was PDN earlier. In 4G, we used to call something called as PDN, packet data network, and now this is going to be DN, data network. Right? So it is nothing but just a different name, but our control plane is completely going to be the cloudified, completely based on the cloud infrastructure, right? Operator have the possibility to deploy their own private cloud to do it, or they can also use the public cloud like AWS, Azure, Google, and others. But of course, they will rely more and more on the private networks, right? So this is something called service-based architecture, and it is very important aspects of 5G. And 5G is going to be completely softwarized, cloudified. 5G core is going to be completely cloudified network, and SV is going to play a major role in that. Now, what is RESTful? The service-based. Now, all the protocols what we used to hear earlier, GTPC. I'll not say GTPU is not completely replaced, but GTPC, diameter, right? Diameter, and n number of other protocols, they are all replaced by HTTP2 kind of protocol, which is using on TCP/IP protocol stack. TCP/IP protocol stack, and on top of that, we are using JavaScript object notation as a serialization protocol. So all our communication is going to happen over HTTP2 kind of protocol, right? Now, what we understand from this is we are moving from telecom infrastructure to IT infrastructure, because our IT infrastructure was already communicating TCP/IP protocol stack and HTTP2 kind of protocols. So we are moving towards from telecom infrastructure to IT infrastructure, and this is something what is going to play a major role in 5G core deployments. Right. Representational state transfer, typically API-based communication. If you're not aware about it, we are going to have a follow-up session for that as well. But this is more related to the IT infrastructure, how the IT infrastructure communicate with each other, application programming interface-based communication. We have some commands like port, get, delete kind of commands, and using serialization protocol as JSON. We will have some JSON format messages that is beyond the scope of this session. Right. Now we have something called service-based architecture where every network function. So we talked about so many network functions. Every network function will act as a producer and a consumer. So consumer will request the producer to provide some services, and producer will respond to that. Any network function which is producer can be consumer also, and any network function which is consumer can be producer also. So any network function, for example, if AMF wants to talk to SMF, right, AMF can request something. So in that case, SMF can be the producer and AMF can be consumer. And if SMF wants to request something, AMF will be producer of that service and SMF will be the consumer of that service. However, how do they know each other? Going back, we are going to have a broker function here, which is called as NRF. NRF is a very, very important aspect here, which is called as network repository function. We are going to have a detailed session on all these network functions at a later stage. But just to give an overview, this is called as the internal broker and this is called as external broker. So any third-party services, if they want to get access to the network services of 5G core, they are going to come via NEF, network exposure function. Any internal application functions, if they are coming in, they have to come via NRF. So NRF is not completely replacing DNS, but okay, Amit, I'll come to that. So just wait for a minute. So NRF is typically a discovery kind of function. It is a central repository function, which is having the state of all these network functions, all the details related to these functions, they are actually kept in the NRF. But any third-party services, they want to have third-party access, they have to come via NEF, network exposure function. So typically we define them as trusted and untrusted. So all the trusted applications will access via NRF and all the untrusted one will access via NEF. NSSF plays a major role for slice selection. So network slice selection function. This is related to the slice management and stuff like that, right? So this is just a quick overview of all these functions. We have already talked about AMF and SMF, which is typically AUSF is nothing but related to authentication. We are going to talk about all these things in some follow-up videos, right? Moving on, a quick summary of terminology which we were using 5G and 4G. In 5G and 4G, we had 4G IMEI, now it is called as PEI. Something what we have is IMSI here, which is now replaced with SUPI and SUKI, subscriber permanent identity and conceal identity. MME is typically now similar to MME. AMF, S gateway and P gateway are SMF and UPF. HSS is UDM, CHF, OCS is now replaced with something called a charging function. PCRF is now PCF, dedicated bearer is like GBR flow, PDN connection. So there are some different terminology. Please note they are very similar, but they are not exactly same. So we have to be clear with this. This is just to give you an idea how to relate the things in 4G to the 5G, right? Just to give an example, in case of 4G, we had GUTI. In case of 5G, we have something called as 5G GUTI. 5G GUTI is called as 5G globally unique temporary identifier. So in 4G GUTI, we used to have 4G STMZ and something called as MME ID, and now MME ID is replaced with something called as AMF ID. Now we are not going to talk about all these things in detail, but just to give an idea, it is a globally unique identifier. And one important difference compared to 4G, in 4G we were using our IMSI as a plain text. In case of 5G, we are not going to use IMSI. Instead of IMSI, we have something called as SUPI, SUPI, which is also encrypted, and this is called as SUCI, which is called a subscriber concealed identity. Concealed identity means it is already encrypted. So you are not going to transmit your IMSI number as a plain text over the air interface. This is just to enhance security. So authentication, we are going to have a follow-up session on authentication as well. But this is just to give an idea how do we enhance security in 5G. So IMSI is not transmitted, SUPI is not transmitted. Only thing what is transmitted is SUCI, which is subscriber concealed identity. Moving on, a quick difference on 4G and 5G quality of service as well. In 4G, our quality of service was based on some kind of bearers. So we had something called as default bearer and something called as dedicated bearer. So the minimum granularity of QoS management was at the bearer level. So we had our QoS management at the bearer level, and we had some QCI values mapped to every bearer to define quality of service. However, in case of 5G, we don't have the same concept. We have slightly different concept. We have slightly different concept here, and now this one particular QoS management can happen at the QoS flow level. So it moved from bearer level, it moved away from bearer level, and it moved to something called as QoS flow. QoS flow, right? So now our granularity is not at the one radio bearer. Now our one radio bearer can also have multiple types of QoS flows. So for example, this one particular tunnel, 1N3 tunnel, which is happening on the NG core network, can have multiple radio bearer, and multiple radio bearers can have up to multiple QoS flows, and multiple QoS flows can have multiple SDFs, which is service data flows. Please note, 1N3 tunnel is nothing but similar to S5, S8 kind of bearer. Now can have multiple radio bearer as well, right? Now in this scenario, what we are going to have is our granularity is going to be at the QoS flow level. So it is going to be finer control on the quality of service. So this one particular scenario is called as one PDU session, and we can have up to 15 PDU sessions. We can have up to 15 PDU sessions possible, right? What are the PDU sessions? What are the radio bearers, QoS flows, and other stuff that we are going to discuss in some further slides. This is just to give you an overview. In this case, we had default bearer and dedicated bearer, and our QoS was tied to those radio bearer. However, in 5G, the QoS is created at the level of QoS flow, right? So there is a question here. So any questions here till now?
Hello, Rajat here.
Yeah.
Then if QCI is not there in 5G QoS flow, then how the VoLTE call is set up?
Sorry, Rajat, so let me correct it here. So I am not saying the QCI is not there, right? So QCI is still there, and now it is replaced with something called as 5QI.
Okay.
So 5 QoS identifier, right? We have QCI value. We still have QCI value, but right now we call it 5QI. That is one. Secondly, earlier my QCI was mapped to a radio bearer. Either it is default bearer or dedicated bearer. So we used to have some QCI value mapped to it. Now all those values, okay, let me just remove this comment. Right. So now coming up to this, so we have all those 5QI values, Now those 5 QI values are not mapped to radio bearers, but they are now mapped to the QoS flow. So what I'm trying to say here is QoS flow is going to be the lowest granularity for the QoS implementation. Does that answer your question, Rajat?
And how many 5 QI values are there? 1 to 9?
No,
Like,
no, there are many more. So there are many more, and even 5 QCI values. So if you see everywhere you see QCI value, you see only 9 values, right? 1 to 9. But if you look at the details, there are so many 65 QCI, 66, 68, 69, 70. Those QCI values are also there in 5G, which are typically defined in R12 and R13 release, right? And used for public safety services, which is like MCPTT and stuff like that. MCPTT is typically called as mission critical push to talk services, right? So this is a misconception that we have only 9 QCI values in 4G. That's not the right concept, right? So our 5 QCI values, only standardized 5 QCI values is 9 what we see. We can have much more QCIs in our network. Similarly, 5 QI, I don't know the maximum number what we can have, but we can have much more than 9, right? So typically, even in 4G, we had QCI values 65, 66, 69, 70. They are used for mission critical services or public safety services, right? So if you really want to know more about it, you just search for public safety in 5G.
Okay. And
right.
in this 5G, one data radio bearer is for one UE.
No, not really. One UE can have multiple PDU sessions. Okay, let me just summarize it here. One user can have multiple PDU sessions. Every PDU session can have multiple data radio bearers. Every data radio bearers can have multiple QoS flows, and every QoS flow can have multiple service data flows for individual applications, right? And maximum how many PDU sessions I can have is 15, right? So I hope that I'm able to make it clear. One user can have maximum PDU sessions, and every PDU session can have multiple data radio bearers, and multiple data radio bearers one data radio bearers can have multiple QoS flow, and one QoS flow can have multiple SDFs. But our QoS implementation, just to summarize, QoS implementation happens at the level of QoS flow, not at the level of radio bearer. This is just to summarize, but I will not be getting to so many other details because we are having limited time. But please feel free to write your questions to me. I will try to answer those questions and give you the right pointer towards these documents. Right. Now, MEC is also going to play a major role in 5G deployments. MEC is called as multi-access edge computing. This is not very new to the IT world. We already had some kind of content delivery networks. We typically call it as CDN, content delivery networks. And we wanted the user data, the data of the network, keeping very near to the user to improve the. Okay, so there is some question, Deepak. Please wait. I'll take your question in a while. Right. So bringing the data to the user. So this is how we can improve the latencies and can also manage our backbone network properly. What do we mean by that? We'll understand that. So bringing the end data near to the user, of course, it is going to improve our latencies as well as it will reduce the load on the backbone networks. And that is why we are coming up with multi-access edge computing. This multi-access edge computing was little ahead of time. So back in 2014-15, Nokia came up with something called as liquid applications. I used to work with, I was associated with Nokia at that particular time, and they came up with something called a liquid application, and they marketed this as coming to a cloud near you. But according to my understanding, it was little ahead of time. What was the reason? Either users were not looking for services which can be provided on MEC. At the same time, we did not have very strong backbone networks. So users were not looking for these services, as well as backbone networks were not strong. So I'll not say it was a failure, but it was not able to get very high rate of success at that particular time. So, but now this is the right time. MEC, this particular slide talks about MEC in nutshell. It talks about multiple use cases, can be low latency communication, proximity services, virtualization, like AR, VR kind of services, and quality of experiences. It also comes with some challenges It also have a lot of characteristics, which is like on-premises proximity. What do we mean by proximity? We'll talk about it. Lower latencies, location awareness, and network contextual information. Please note, I'm just going quickly on this particular slide. This is one slide where we can spend more than 60 minutes because each and every point here is a something related to MEC, but we'll not get into those details. So there are typical use cases of MEC, network performance related use cases, where local content caching, where all the static content and frequently used content can be cached. So MEC is more towards caching. So many of you have already heard about caching. So it's more related to caching, but not only limited to caching. It is much beyond that. We can optimize our video delivery. We can also do the network optimization. It can also support for third-party services like connected vehicles, video analytics, big data, active devices, location tracking, and security and safety kind of devices. Customer-oriented services where we are talking about 3D services, AR, VR, right, intermediate data processing, and low latency applications. So these are the three things. These are the three different applications we are targeting for MEC. Now, what is MEC? MEC is all about bringing your user plane, UPF, near to the end user. This is just a mission statement of MEC, bringing the user plane functional near to the UE. And how do we achieve it? What we can do is we can deploy our UPF. We can deploy our UPF with the base station itself. If many of you have worked with Nokia, so Nokia brought in something called as HSP adapter back in 2012-13. So that was also bringing user plane near to the base station. So co-locate with the base station. You can bring your user plane near to the base station. You can also co-locate your user plane with the transmission node with some kind of MEC controller, right? Multi-access edge computing controller. We can also have our user plane very near to the network aggregator. How do we achieve this? Bringing to the network aggregator. And finally, you can also have your UPF at the core network data center, which is nothing but the generic kind of architecture. Now, we will not be able to cover all these things in detail, but yes, just to give you an idea about MEC, MEC is all about bringing the user plane to the end user, closer to the end user. However, it is okay. Rajat says, is it a CUDU concept? Rajat, it is not completely not related to CUDU at all. CUDU is all about this part. The NR can be divided into CU, DU, and RU. I'm not talking about it. I'm talking about the bringing the core network closer to the end user. Core network closer to the end user. It has nothing to do with the split architecture in the RAN. I'm not talking about RAN split here. I'm talking about the core network split. We are bringing the user plane closer to the end user. Right. So just to answer Rajat's question, it is not related to the radio. MEC is not related to the radio, but bringing the core network functionality near to the radio. Right. So it's slightly different than the RAN split architecture. Right. Moving on, just a quick overview on slicing. What is slicing as we talked about? It is going to divide one physical network. So we have one physical network going to get divided into multiple logical network. What can be those logical network? One logical network can be EMBB, enhanced mobile broadband. Another logical network can be URLLC, ultra reliable low latency communication. And the third one is MMTC. Please note, these are not the only slices we can have. We can have lot of slices. We can have lot of slices which can be, so these are the typically standard slices which are defined in 3GPP. And now we have defined another standard slice also, which is for V2X. But we can have a particular slice, for example, for police, another slice for 5GR, 5G network for railways, another slice for MCPTT services, which is mission critical power push to talk services. We can have another slice for a industry, one particular industry, and I can even have a slice for IPL match. Right. I can even have a slice for IPL match. So there is a question related to the slicing. I will talk about it right in a while. So we create a slice as and when required. We can do the orchestration of that slice when this is up and running, and we can terminate the slice when it is not required. One user, how many slices there can be there in the network? There is no such number defined as of now. At least I'm not aware about that number if it is there. But one user, one particular UE, one UE can get access to up to 8 slices at a time, right? So I can have many slices in my network. It can be created even for a IPL match as well. It can be created for police. It can be created for industry, right? So slicing gives you a lot of control on the resources. And how do we do it? We'll talk about in the next slide. But one user can access maximum 8 slices at a time. So one particular user, so they're typically defined with something called as NSSAI. We are not going to talk about all these details, right? It's NSSAI and the identification related to the slices. So there is question. Okay, will there be interference? Will there be interference between two slices? Not really, Rahul. Let me talk about it, a little more about it, and then you'll get an idea how this is going to happen. Right. So slicing is something. Okay, slicing is something which is very critical, very new aspect of 5G, and this goes much beyond QS. So QS will also happen within the slice. But slicing, which works on the top of QoS and can completely isolate the resources. Please listen to this carefully. It can completely isolate the resources in radio network, transport network, as well as core network, right? So if we really need to support slicing, we need to have the support of the slicing in radio network, core network, as well as the transport network. So any of these networks, if they don't support slicing, right, slicing is not going to work. So we need to have that support in the radio network, in the core network, as well as in the transport network. So we need to have 5G transport network, 5G TX network, transport networks, which are slicing capable, which can support in slicing. We have various aspects of slicing in 5G transport as well, which is called as hard slicing, soft slicing. We have some new routing mechanism also called as SRTP, which is called as segment routing. Segment routing. So segment routing is also very important aspect if we really want to support slicing in the transport networks. So there are a lot of new concepts coming in with the slicing. So let's talk about it. So what we can have is we have a 5G network. When I talk about 5G network, a part of my 5G network can be radio. A part of my 5G network can be transport, and a part of my 5G network can be 5G core. So first important aspect here is if we really want to support, we have to support this in radio, we have to support this in transport networks, and we have to support this in core network. And all these things has to be managed individually, and has to be created in a much better manner. And for that, what we need to have is we need to have a management and orchestration. That we'll see in the next couple of slides. So what we have here, just to take an example, we have 4 or 5 different scenario here. We have one application which is URLCC, ultra reliable low latency communication, and we have EMBB, enhanced mobile broadband, and MMTC, massive machine type communication. Another slice can be related to the public safety. Another slice can be related to some industry, right? So there can be n number of slices. All these slices, they rely on the same infrastructure. Please note, my physical infrastructure is going to be shared. What we are going to do is we are going to do the logical separation of this physical infrastructure. And how we are going to do it, that is a very, very detailed discussions. We can also have a slicing related discussion at a later stage, right? And not in this session, but in some follow-up sessions. But slicing is a very, very interesting aspects of 5G. How we are going to play with this in radio, transport, core is going to be very interesting. So what we have here is we have an end-to-end slice for URLCC, which is typically using some applications related to the URLCC. So this is the clients and this is the servers here. We have another slice for the EMBB, There are another slice for MMTC or public safety services, and there are another slice for, sorry, MMTC, another slice for public safety services. All these services, all these slices are completely isolated. Completely isolated. They can have some dedicated resources. So they just give me a minute. I'll come back to your question. So those resources can be dedicated and those resources can be shared as well. So there are different scenarios how to implement slicing, but end of the day, it gives you end-to-end consumer experience. So this is completely isolated network infrastructure which is given to a particular customer or particular service verticals, right? Now there were some couple of questions here. Is the concept of slice totally different from that of radio? Tejas, if you see, the question itself is not very relevant here, because what I'm saying is we are talking about slicing which has to be end-to-end. Slicing end-to-end means it is a completely isolated network. So typically in a simple manner, I can say I have a virtual network. So we used to have a concept of MVNO, mobile virtual network operator. Please consider this every slice as a different, no, every different virtual network operator. One virtual network for URLCC, one virtual network for EMBB, one virtual network for MMTC, and one virtual network for public safety services. Slicing will be decided by the network vendor. Vendor means it will be typically implemented by the operators, right? So it has some it has to have some support by vendor equipments also, but it is typically defined by the operator to whom they want to sell this particular slice. What method is used for slicing in the radio network? Yes, radio network is typically going to talk about multiple radio pairs. I think one API called created call slices. I'm not sure about Varun your question. Now then, how can one user access several slices at a time? Yes, there is a possibility where one user can use multiple slices at a time, right? So the every service they will be using in different DRB. So there are a lot of questions. How will 5G slice will help in IPL sports? So you can have some MEC kind of application where you want to watch all the videos, live feeds of all the cameras in the IPL stadium. So many questions. Can you slicing with other access technology? Yes, Manuel, there are some possibility, because 5G core supports about two things. One is 3GPP technologies, and it also has support for N3GPP technologies. So slicing is support for 3GPP as non-3GPP technology. Non-3GPP, when we talk about, we are talking about Wi-Fi. We are also talking about wireline kind of services. Slicing in radio is SD-RAN related. I'm not sure SD-RAN, if you're talking about software defined radio access network, that can be a common concept here, but it is much beyond that. I got your point, defined radio access network, but it can be much beyond that. It's not only radio, it is radio, transport, as well as the core network, right? Can you, from the end user point of view, okay, so there is a question from Mr. Jujhar. So this is the last question I'm taking on the slice. So end user view. So if you see, let's say I have a user which is typically using an application called as URLCC. So I have a car here. This car is using typically two services. One is it is communicating with V2X. V2X is typically vehicle to X, where it is communicating with all nearby vehicles, as well as it is communicating to the red lights and stuff like that. At the same time, you are having some infotainment kind of services, right? So when I say infotainment kind of services, in the same car, you are having V2X control and infotainment kind of services. So for V2X kind of services, it can access those services via URLCC, and it can be using some services from this particular server, which is typically the V2X server. However, when I say the user in that car is using some kind of infotainment, and for that infotainment, we need EMBB kind of services and provided by some servers. Here, I have the same user here. Which is using two different slices. One slice is related to URLCC for V2X application, and another slice for EMBB, which is typically for infotainment, right? So I can have this scenario where one user can using multiple slices, and this is possible for 3GPP technologies as well as non-3GPP technology. One important aspect here, which I forgot to mention earlier, is 5G provides interactivity, interoperability with 4G. 5G till now in the current releases have no definitions for 2G and 3G interoperability. 5G is not going have not defined any interoperability with 2G and 3G network. So as of now, the releases what we have, 4G talks about only interoperability with. Why? Because they say the running 2G, 3G, 4G, 5G network is not cost effective. So most of the operators are going to scrap their 2G and 3G network, and finally they have to have an interworking network of 4G and 5G. Right. So if you look at the definition, there are no specs defined, no specification, no 3GPP specification defined for interoperation of 2G, 3G with 5G. It is only the interoperation for 4G with 5G. Right. Moving on. Okay, so there is a question from Juzar. It says, how shall operator cater to it? Juzar, I'm not sure about it, because if you see most of the operators today, they are relying on 5G, 4G already, right? Mostly what they're going to do is 3G is going to get scrapped very soon. But 2G, how they are going to cope up with this challenge, I'm not sure about it. I'm not sure about the implementation of this. But yes, this is something what we have in the specs. No interoperability with 4G and 2G for sure. Right. Now, this is another scenario where we are talking about radio network, and the transport network and the core network. So we can have different kind of access. We can have some PHY and MAC layer which are common, but some other layers can be separated. We are not going to get into these details. We can have all dedicated layers for another slice. We can have some common layers for some of the slices, and we can have some different layers for different slices as well. Right. So now what we have here is like multiple options are possible. And if we have not talked about that in detail, we have something called as RAN split architecture. RAN split architecture talks about a separation of DU, CU, and RRU. We have different options available on these DU, CU, and RRU, and some of those options will be implemented in different kind of RAN split architecture, right? So, however, we need to have similar separation at the transport layer. In case of core network, we can have separate virtual machines. So, if you look at this, we have a separate SMF and UPF for one slice, which is like Polis. We have another SMF or UPF for another slice, and we have another SMF or UPF. Please understand, these SMF and UPFs are nothing, but they are some kind of virtual machines. They are some kind of virtual computers being used on the 5G cloud network, right? So we need to get into so many details to understand what is the virtual machines. And I'm sure some of you have idea about the cloud networks, and that is where the VM plays a very important role. Moving on, last but not the least, to manage all these complexity what we discussed, we need to have a very, very good OSS, which we used to call in past. OSS later evolved into something called as SON, self-organizing network, and self-organizing network are now called as MANO, MANO, which is typically management and network orchestration, right? Management and network orchestration. Now, when I talk about management and network orchestration, we have a radio network. Just to summarize it, radio network, and we have transport network, and we have core network as well, right? Now, all these radio network, core network, transport network, they can come from different vendors, and they will have their own orchestrations, radio network orchestration, transport network orchestration, and we will have core network, right? And all these typical orchestration can be managed by a centralized MANO, which can do slice management function as well as management and network orchestration. So what we have here is a hierarchical architecture for different kind of orchestration, radio, transport, core network orchestration, and finally what we have on top of that is a centralized MANO, we can call it, which is the umbrella term what we have here is. However, typically we are all going to have some third party kind of implementation, because the radio network, we are talking about lot details about the ORAN, Open RAN, right? So Open RAN is also going to is picking up the pace very soon. We will have a lot of implementation of ORAN as well. Transport networks are going to be mostly SDN based transport network or SD-WAN kind of transport. And our cloud core network are basically all cloud defined network function. We are all virtual, so typically we call this as a VNF, virtual network function. So there is a lot of importance of MANO, which is going to play a very major role in managing all these things with the finest details. Right now, this is the completely this is what INFE reference architecture by ETSI. We'll not get into these details, but this is similar to the cloud architecture. What we have here is the physical infrastructure. The physical infrastructure is divided into some virtualization, some virtual machines, and all those virtual machines are translated into some virtual network function. All the virtual network functions are managed by some EMSs, element management system, which is on the top managed by typical OSS BSS, which is going to integrate with orchestrator. So we have the hardware architecture managed by something called as VIM, Virtual Infrastructure Manager. All the VNFs, virtual network infrastructure, virtual network functions are managed by something called as VNF manager. And finally, all these things are mapped to orchestrator, and orchestrator is going to communicate with OSS BSS. So typically, OSS BSS is going to have a bigger picture. It is going to have connection towards the network, as well as we typically call it southbound interfaces and northbound interfaces. So southbound talking about the network, and the northbound we are talking about interfacing with the CRM and the business processes and stuff like that. However, this is again a detailed subject about the network orchestration. We'll not get into the details of this, but that's all what we have for this particular session. It's lovely having you here. If you have any questions, if you have any question, please feel free to ask those questions. Before we take up the question, just wait for a minute. Before we take up the questions, I will request you, my colleague Kuldeep has shared a link in the chat box, which is about the feedback about the session. So please fill the feedback forms and let us know. Let us know what are the things you want to have in the next few sessions. And please feel free to ask those questions. And I'll request everyone to fill the feedback. If you felt bad about this, pretty okay. Please fill your feedback forms, because feedback is something which helps us to improve our further sessions. If you want to have a look at the video of this session, I will request everyone to subscribe to our YouTube channel. We will be uploading this video soon or on our YouTube channel, and you can have a look at this video at a later stage also. There is a question related to slides. I'm not slides, but you will have a link to this video on our YouTube channel. Right. So, and if you need any more information, please feel free to visit our website, which is nanocellnetworks.com, or write an email to info@nanocellnetworks.com. You can also connect to me on LinkedIn. You can easily find me on LinkedIn. I'm Sanjay Kumar on LinkedIn. Right. So if you can type just Sanjay Kumar, I will also share the link of my LinkedIn URL in this particular network. In this chat box. And if you have any questions, please feel free to connect on me and ask those questions. So that's all from my side. Please feel free to ask your question. Please unmute yourself and ask those questions.
Sir, Abhishek here.
Yeah, Abhishek, please.
Yeah, sir. Actually, I belong to IT domain rather
domain.
than IT domain.
IT domain. Okay, great, Abhishek.
Okay, where the only similarity which I found with 5G is a bit of wireless 6. Okay, and sir, but my basic interests are to get into the to the MU, and the beamforming and the radio aspect of technology.
So, Abhishek, we
yeah.
have quite a lot of. So you can do it. We will be uploading many videos related to MIMO and DSS, dynamics sharing, spectrum sharing, and stuff like that. So please subscribe to our video. In next few days, you will see a lot of videos related to the topics what you mentioned, right? And we have a subject matter expert for. I'm not the subject matter expert for radio, right? But we have subject matter expert for radio. Please connect me to on LinkedIn. Connect to me on LinkedIn, and I will try to help you with some of the standard videos with that. Is that okay, Abhishek? Any other question? So
what my query was actually,
yeah.
What my query was in continuation to the earlier question was that, see, as far as the core network or where the actually transport happens after the LT.
Just give me a minute. Just give me a minute. So I'm just sharing my URL for my LinkedIn profile. Please feel free to connect to me on LinkedIn as well. Yeah, Abhishek, please ask your question.
Yes,
Sorry
yes.
for
So what I was asking was that no, like core network is another part. Your radio network is another part, and
that's
there will
correct.
be. So I am only interested in the radio designing aspects, where the electromagnetic spectrum and probably there is a like as I spoke about multi-band
Yeah. So
beamforming
Abhishek,
and all these things.
sorry to cut you short. If I got your point, but what I wanted to say is I'm not a subject matter expert for radio, right? So what